Now let's take a look at the Pythagorean Theorem. The Pythagorean Theorem is the way to find the measurements on the side of a triangle. But it doesn't apply to any triangle. It's a specific type of triangle. A right triangle. What is a right triangle? A right triangle is the type of triangle that has a 90-degree angle. Because it has a 90-degree angle, we can use the Pythagorean Theorem. Let me explain. The Pythagorean Theorem, we need to have some vocabulary. The first part is the hypotenuse. The hypotenuse is the side that is always the longest side, and also it's always across from the 90-degree angle. The other two sides that create the 90-degree angle, which could be called the side or a leg, create the 90-degree angle, and for the purposes of this lesson, we're going to call them sides instead of legs. So this is an illustration of two sides and the hypotenuse. Traditionally, the Pythagorean Theorem, you're supposed to use the equation a squared plus b squared equals c squared. Now we're going to do the same math, but we're going to take away all the algebra. Let's simplify the Pythagorean Theorem. So let's start by a situation where we're looking for the hypotenuse. They give me a measurement of 3 units. It could be feet, inches, whatever, doesn't matter. Same thing for here. And we're looking for the hypotenuse. How long is this side? It could be in a word problem, and it could be shown in many different ways. But at the end of the day, we're looking for the distance from that point to that point in a triangle. So, if you're looking for the hypotenuse, your first step is to square your numbers. Whatever numbers they give you of each of the two sides, square them. Now, what we mean by square is by taking this number and to the second power. What that means is that you're going to multiply this number by itself this many times. In this case, because this 2 is the same thing as 3 times 3. 3 times 3 is 9. I'm also going to square the 4. 4 squared is 16, which is the same thing as 4 times 4. Step number 2, I add. I add the 9 plus the 16, which gives me an answer of 25. Step number 3, I take the square root of my answer. The square root of 25 is 5. The square root is the opposite of the square. The square tells me to multiply this number by itself this many times. The square root is telling me what number multiplied by itself gives me this number. 5 times 5 equals 25. Therefore, the square root of 25 equals 5. So in this triangle here, if this is 3, this is 4, that has to be 5. That's when we're looking for the hypotenuse. Not always are you looking for the hypotenuse. Sometimes you're looking for one of the sides or one of the legs. Example here. In this example, we have a measurement of 8 and a measurement of 10. Because we're looking for one of the sides, just like in the hypotenuse, I'm going to square my two numbers. In this case, it's 10 squared and 8 squared. 10 times 10, or 10 squared, equals 100. 8 squared, which is 8 times 8, is 64. Now, different than the hypotenuse when I added my two answers, for the side, I'm going to subtract my answers. So we do the subtraction. 100 minus 64 equals 36. Last step, just like in hypotenuse, I did the square root of the answer. Now I'm going to do the square root of my answer. Square root of 36, or one number multiplied by itself, gives me 36, which is 6. 6 times 6 is 36, so that means that this side has to measure 6. So, for the Pythagorean Theorem, there's some things you need to remember. You're always going to square, you're always going to square, you're always going to square root, you're always going to square root. The only difference is, am I going to add or am I going to subtract? So how do you know the difference? This is how you know the difference. If you notice, all of these here start with the letter S. So if you're looking for a side, you're going to square, you're going to subtract, and then you're going to take the square root. If you're looking for the hypotenuse, there is no pattern. So remember, side, subtract. That's the easiest way to remember how to find these. Now there's another part that we can talk about, which is the Pythagorean triples. Let me erase and I will show you. A Pythagorean triple is three numbers that follow the pattern of the Pythagorean theorem. You will come across a lot of triples on the GED, but you will see two major types. The 3, 4, 5 triangle and the 5, 12, 13 triangle. If you notice in the examples before, the first one we used was a 3, 4, 5 triangle. Let me show you a little trick. If I multiply all these numbers times 2, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. Those were the numbers for the second example. They're both a 3, 4, 5 triangle, but they are multiplied by a larger number. I can do it times 3. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. Times 4. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. So if you happen to recognize two of these numbers, then you already know what the third number will be. The other form of Pythagorean triple you will come across on the GED will be a 5, 12, 13. Same thing, you may see it 5 times 2 is 10, 12 times 2 is 24, and 13 times 2 is 26. Or times 3, 5 times 3 is 15, 36, 39, and so on. So if you take the time to become familiar with these combinations of numbers, you may be able to recognize it and be able to do a Pythagorean theorem problem even faster.